Can you hear me?
Yeah.
Okay. So you showed me that you're taking a test on the quadratic equation and formula and graphing and a bunch of things that it seems a lot.
Yeah.
And how many days do you have to prepare?
Not a lot. Like
Okay.
like 3,
3 days to study?
2.
So
Yep.
when is your test? Thursday or Friday?
Um, Thursday at the end of the day.
Okay. Thursday at the end of the day. So technically you just have today and tomorrow, and then Thursday you just want to kind of review and
Yeah.
kind of make sure that what you know today and tomorrow. Hey, I got you, dude. Okay, so let's do
All
this.
right.
Okay, did you at least try these two problems or nah?
I didn't do that. I
Okay.
was probably
Hey,
I
hey,
was
hey, hey,
studying.
hey, let's just stop. It's cool. Hey, that way I know what. That way we can just go for it. We can just try them. Okay, so I because I saw what you're gonna be doing on your test. You showed me, and then and I'll just say it. It's factoring the quadratic formula equal to 0, solve for x, right?
Yeah.
Graphing a quadratic formula,
Yeah.
finding the x-intercept, and then there's something called the vertex.
Yeah.
What is that, dude?
I don't even know, right? For like, I think it's like the vertex is there's something in between it, like where like the split in between like the line. It's like I don't know, bro.
Oh, I did. I forgive you.
But our teacher hasn't even been at school in like 3 weeks too, bro.
Hey,
So
hey, again, those are stuff out of our control, dude. Those are stuff that we don't worry about. Okay, right now we're just gonna go ahead and just tackle this. I'm gonna try to do the best I can to explain to you it in a way that you'll know what's going on, because I think what I know is that you have your algebra pretty good. The examples. Okay, so let's first of all let's go through to some easy examples. All right. Hmm. I took off today earlier, dude, from work.
hmm.
Yeah, I was like, nah. That's why too. I was like, nah, this is more fun. Honestly, dude, like honestly, like yeah, I know. Make fun of me. Okay, so let's do a simple one, okay? Um, let's do one with single, just so we can get the hang of it, okay? So let's do x squared. So this is gonna be a practice problem, right? So review. So review problem, okay? And this
Yeah.
is and the problem that I'm gonna show you is what we should have learned previously. Make sense? Yes? No?
Yeah.
Maybe? Okay. So none of the new stuff. So let's do simple problem. Let's do x squared um plus x, right, minus 42 equals 0. Okay. I'll give you I'll give you like a minute to two to try it on your
Sure.
own. Try to factor it. And what I mean about I want to see this, bro. Like this. Es lo que quiero ver.
Okay.
This. Okay? So I want to see this set up, right? And then work it out. And then at the end you tell me your two answers, okay? Try to see how much you can get in the next 2 minutes.
All right. Mm, All right. You're muted.
It's such a boomer thing. My bad. All right, dude. Tell me what to write.
All right, so X on the first two, and then +7 on the first one, and then -6.
Okay. Yeah, that's right. Right.
And
That's right.
then
Uh huh.
it's just like the two separate ones, right? It's
Yeah.
just
What do I do?
and then equals 0, and
Mm-hmm.
then X -6 equals 0.
Okay.
And then on X +7, so you subtract 7 from both sides, and X equals 7.
Mm-hmm.
And
Right.
then, yeah.
That's a cool thing. Like, see, the thing is, once you start getting the hang of it, you can actually do those two steps at the same time. You can solve the two equations like, I see,
Yeah.
right? Um. Okay. Anyways, do whatever you want to. This is your life. So x equals -7 for one, and x equals -6 for the other one. Is that what you got?
Or 6.
Oh, my bad. That's right. X equals 6. Oh, you see? Mira, me equivoqué. +6. Okay, cool. Yeah, that's it. And I'm glad you kind of like, pointed that out. Good. All right, perfect. So now let's go con estos. Okay?
Mm-hmm.
So, what was it? 3x squared? What was it?
Yeah.
Plus 2x minus 1. And that equals 0. Okay, so now it's different, right? So now it's different. And let's go. I'm gonna go back to the problem that we did where we had that exact example. And here it is. This was the part. I'm gonna go through it, okay?
Mm-hmm.
So remember, this was our problem that we started. 4x squared plus 8x plus 3, right?
Yeah.
And we want to see if we can factor this. So first, we looked at every single value. 4x squared, positive 8x, positive 3.
Yeah.
First thing we do. And then we say, can we factor something out of each thing or each part? And in this case, we don't. 4, 8, and 3, there's no common denominator, right? X squared, X, we can factor in X from those two. Pero este primo no X
Yeah.
there. We're good. Okay. So right after that, the next step is to see if we can factor it in this cool way.
Yeah.
Right? So so right off the bat, we know that what goes here and what goes here, if they multiply together, should give you what?
4x squared.
Correct. So the yellow values would be potential candidates that would work for those, that would fit perfectly there, right? Because
Yeah.
4x times x, right?
Yeah.
2x times 2x, right? So we can
Yeah.
have 2x here, 2x here, we can have 4x here, and x here. So right off the bat, I know for sure that's going to work. It's going to be one of those two.
Yeah.
Okay, we're done with that 4x squared. Let's not worry about that. We're good. Okay. Ya acabamos con ese. The next one we looked at when we went through the example is the last number. And similarly, the last two numbers in each of those parentheses have to multiply together and give you positive 3. And we found two possible, possibilities. 1 times 3
Yeah.
equals positive 3, and also -2 times -1 times -3, right?
Yeah.
That also gives you positive 3. So we found the other two that will work.
Yeah.
Cool. Oh, cool. We're done. I'm not going to worry about this guy or this guy anymore. I already got potential candidates that would work.
Mm-hmm.
Now, what combination is it going to be? Is it going to be these two? Dun, 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 dun. These two. You know what I mean? So
Yeah.
what's going to help you out is going to be this guy. This is guy that's going to give you the answer. So let's not waste time on going through that. Let's actually work on that because that's what I wanted to teach you today. That's what we left off last time. Okay? But you kind of understood or no?
Yeah.
Oh, nada más me
Yeah.
dices que sí. All right, cool. All right. First question: can I factor something out of the whole problem?
No.
Okay, good. All right, so let's set it up. Right off the bat, I'm gonna apologize, Luca, because the when you showed me that assignment, not assignment, but the well, that was the sheet that your teacher gave you as like how you would solve the
It was
problems,
like
right?
during, yeah, it's just like during class she would like do it, but then like she filled it out and then she just gave it to us, and then like the sub, like, bro, I don't know what the sub was doing, bro. She was like, bro, it's like, bro, her way of like she, I think she was like from like somewhere else, and like she would just like explain stuff, and then it just didn't make sense, and
Mm-hmm.
then she would just like tell us to like deal with it, and like not to like she wouldn't like really care about it much, so it
Did
was
it
like,
did someone go like this? Me like this, and then they went yes. Can you explain it? And then she's like yes, or what? Or no, no one asked. Or what's the vibe there in your class?
nah, no one asked because it was just awkward because it's like, bro, it's she. My teacher was supposed to be back last week. She wasn't there all week, and then she was supposed to be back. She was there for the first week when she introduced the unit, and then last week she wasn't here. She told us she wasn't going to, and then this week she was supposed to be back to like help us like study before the test,
Mm-hmm.
and she's also not here. So it's and now it's been like the same sub. So
Yeah. Hey, good luck,
yeah,
man. I wish you the best. Also, just keep in mind that schools get evaluated by the state test, right? So make sure that
yeah,
on the state test you do good. These tests, man, it could be even the teacher wanted to take vacation during this time because this is a difficult subject to teach. I'm gonna be real. It's
yeah,
it's confusing. You know, this what I'm gonna explain to you right now. I feel personally, um, it's one of the most like puzzly parts of transitioning from like algebra to algebra 2, or from like you
yeah.
know what I mean, or from like a pre-algebra honors to an algebra. It's this little part. Okay, so let's go through it. Okay, yeah, mucho chisme. All right, so let's look at the let's first focus on what we know how to do first. So what are we gonna tackle first, Luca?
Uh, like like the first like parentheses, like getting 3x squared and then
Okay, so
negative
let's do
one.
that. Yeah, I'm glad you. That's the first thing you said. 3x squared. Okay, what what are the possibilities that can multiply to 3x squared? What would go
Uh,
here? Mm-hmm.
um, um, 3x and then x,
That's right. Mm-hmm.
then negative 3x. Oh
Okay,
wait, oh
not
wait,
there.
yeah,
We don't use it there.
okay,
That's the cool
then
thing. The first one is just positive, just
okay,
because
yeah.
I mean,
Oh,
sidetrack. If you had the problem like this, negative 3x squared plus 2x minus 1, you're not gonna get that.
yeah,
Those are
yeah,
things that like honor kids get, or like in classes that are a little bit higher, because there's one thing that you got to do before. You got to factor out a
yeah,
negative, right? So then you would have negative, and then you would have 3x squared minus 2x plus 1 equals 0. And then you would have to factor that one. You know what I'm
yeah,
saying? That's it. Anyways, okay.
okay.
Cool. Let's go back to this. All right, we have 3x squared. I mean, 3x and x, right? Okay, cool. Now let's do the other one. What would be the other possibilities for this one?
Um, mm, negative, negative. Oh wait, no, that doesn't work.
This one. Two numbers that multiply to negative 1. That would go here and here.
Bro, I am lost. Negative one. One and negative one?
That's right. One and negative 1. See, you got it, dude. That's so small. So it's so it could be you said 1 and negative 1.
Yeah.
Mm-hmm. Good. Is there anything else? So
Um,
that means you could either you can have a 1 here or a negative 1 here, right? Okay,
yes.
what else? What's another way?
Negative 1 times 1.
That's right, dude. I know, dude. It seems that it's like, wait, really? Yeah, is that it? Those two. Why? Because they can swap places, dude.
Yeah.
And it does affect it because remember, where this value is going to depend what it's going to multiply with. And the right off the bat, like think if this negative 1 is here, it's not going to multiply with the guy that's here. It's going to multiply with what you're going to put over here. So if this is negative 1 and you're multiplying times that value, it is going to matter where if x goes here or 3x goes here.
Yeah.
Okay, so in other words, and let me erase it. Let me erase this. I want to talk about it first, dude, just so it could be like, you can kind of force the make sense of it before we actually work it out. But this is what I'm saying. Here, which are those two values that you found to equal negative 1 when you multiply, you got two of them. 1 times negative 1 and negative 1 times 1. You could be like this, right?
Yeah.
Or it could be like this. Okay? So either the negative 1 is over here or it's over here. Yes? So far so good?
Yeah.
Now, if it goes here, so let's put 3x and x because that's the only option, right? So let's just add it in the problem so we could just work it out. So we're going to do 3x inside and we're going to do x here. All we're now have to do is is it going to be negative 1 here or plus 1 here? Now, right? So that's what we're going to try to do. So let's not try to solve it yet. Let's just see, okay, before I get into it, what can I use to make my life easier or to give me a hint? Right? What do we have here?
Positive 2x.
Positive 2x. That's right. That's what we need to get. That's the outcome of what we put here. Like if we put plus 1 and negative 1, if we put that, the outcome of that should give me this, right? If I put negative 1 and plus 1 here, the opposite, then the outcome should be here. And, and this is a trick. This is a trick, dude, to know where the negative goes. So let's look at here at that 2x. Is it positive or negative?
Positive.
Positive. So you know that the positive value needs to be bigger. It needs to win.
Yeah.
Right? So, is that enough information for me to give you so you can solve it?
I mean, with the numbers given?
I'll repeat it again and I'll give you another shot. Okay? So, we already know that 3x and x goes here. So, the only possible two options that we have in this scenario right now is either it could be plus 1 and negative 1, which is this guy.
Yeah.
Right? And we know, Luca, that if we put whatever goes here, what is it going to multiply with? The 3x or the x?
The 3x.
No.
No.
Okay. What?
Yeah.
This guy's not gonna multiply with the one he's inside. No. He's bored of that guy, dude. Sees him all the time. He's there. No. If he gets a chance to get out or multiply, he's gonna be like, "Hey, ahí nos vemos," and he's gonna go and see what's on the other side of the fence. So if the negative 1 is over here, what is the negative 1 gonna multiply with?
With the 3x.
That's right, with the 3x. So the outcome of negative 1 and 3x multiplying, what's the outcome of those two?
Negative 3x.
Negative 3x.
Yeah.
But if it was plus 1 on this side, what would be the outcome of those two multiplying?
3x.
Okay. So, now that I've told you that, do you think that's enough information for you to tell me what goes where to get positive 2x?
Yeah,
What is it?
but negative. They're all gonna be 1, no?
Okay. What do you mean 1? I mean technically like
If
1
you
and
put
1, right?
yeah,
Okay,
it's gonna
but one needs to be positive and one needs to be negative because we need to get -1 when those two are multiplied. That's why these are only two options. Those are only two options. It could either be negative and positive, or it could be +1 and -1. That's the dilemma right now. That's the trick that I'm kind of pushing you to figure out.
and we're trying to get it to be 2x.
Yeah. And remember, and I mentioned earlier, if I put -1 here, this -1, what is it going to multiply with?
It's multiplied with the x.
Okay, with the x. So when you do that, the outcome of that is this, right?
Yeah,
Okay. Now, what would go on the other parentheses if we put -1 on this side?
positive.
So let's put it +1. So who would this one multiply with?
The 3x.
Let's multiply with the 3x. If those two together, what's the outcome of those two?
3x. Oh, so it would be -1 and so it'd be -1 and then +1.
We would have it the way we have it here, right?
Yeah.
Because now that you see what each pair kind of spits out, how they combine, then you're like, oh, dude, this is a simple addition and subtraction problem.
Yeah.
What's -x plus 3x?
2x.
Which one is the bigger number here, 3x or x?
3x.
And what's the sign of 3x?
Positive.
What's the sign of the value inside?
Positive.
That's what I was trying to tell you. So this value here is pretty much gives you the answer of where the negative or positive are going to go, because it's
Yeah.
just you just know that it's going to go with the number that's going to multiply and become the largest, because that's the winning sign. Es el que ganó. El positive wins, right? So if you
Yeah.
have two numbers that it's 1 1. Oh, dude, based just by looking at it, my 3x is going to be bigger. 3x times 1 is 3x. X times 1 is x. What's the middle one? Oh, 2x. Okay, it's got to be positive. So the 3x is positive and the other one, x, is negative. Right? So that means if I want this guy to be negative, that means it's going to be -1. If I want this guy to be positive, I got this one. I, kind of explain it different ways. But how do you feel about that logic?
Yeah. Good.
Good?
Yeah.
Okay. Let's review faster in order, because we kind of went like this, we kind of went like this, then like that, then like this. You know what I mean? So let's just kind of go through it cleanly. Deal?
Yeah.
All right. And sorry. All right. So what we did first is we wanted to know what values equal the highest binomial, right? The highest exponent, which is 3x squared. And right
Yeah.
away, 3x times x. Cool. Those are the only ones. So we just put them in here. I don't need to worry about 3x squared. It's already done with. Then I'm look at the last value, which is negative. These are the two possible ones. And then I just decide, okay, what is going to go inside? Well, I see that in the middle is 2x, positive 2x. So that means where I'm going to put this value or this value, it depends, because I want the biggest value to be positive. So that means that 3 needs to multiply with whichever value it's going to make it positive.
Positive.
So 3x multiplies with the 1, so that means +1 goes over here. Okay? So now
Yeah.
we're just left with 3x minus 1 equals 0. X plus 1 equals 0, right?
Yeah.
We add 1 to both sides, right? Then we're left with 3x equals 1. We divide by 3 to both sides. X equals 1/3.
Yeah.
All right. All right, you do the harder one. What do I do?
Subtract 1 from both sides.
All right.
And then yeah, that's your answer right there.
So good. All right. So x equals -1.
Yeah.
All right. Let's go and do the second one. All right. Let's write it together. Okay. What was it? 6x squared?
6x squared and then 13x, I think it was.
Does it have a sign or no sign?
Plus 13x.
Oh, okay. Hmm?
And I forgot the rest.
Dude, I'm the one that's old, bro. Plus 6.
Yeah.
Plus 6 equals 0.
0.
Okay. So, same thing. Let's look at the entire problem. All three parts, right? 6x
Yeah.
squared, right? Can I factor anything? Hmm?
No? Or
No.
no. No.
No? No, okay. All right. Okay, so let's factor it. All right. So let's start. What would be my first well, tell me. Walk me through it, dude.
So the first two would be 3x.
Mm-hmm.
And 3x again. Oh, wait, no. I'm dumb. Wait.
What's going on? What are we doing first? Tell me
I thought I was thinking about 9x. I don't know why.
All right, for sure. Okay, so which one are
And
we
then
looking at first?
so 6x squared.
Okay.
So just so 6x and then x
Mm-hmm.
and then
What else? Is that
yeah, no.
Are those the only two that multiply to 6x squared?
Yeah.
Okay, those work. Is there anything else? Are there any other two numbers that multiply to 6x squared?
I don't think so.
All right, so let's check it out. So we have 6x squared, right?
Yeah.
There's two parts there.
Oh, wait.
Wait.
So
What?
2x and then 3x. I keep thinking that they have to be the same number. I don't know why. Like like I keep thinking like it has to be like the same number to. I don't know why I keep thinking it's them, but whatever.
No, you're good. Okay. What else?
3x and 2x.
That's right. Or it could be x and 6x.
Yeah.
Right? Okay.
Yeah.
So write that down. Are you writing this down with me, dude, or are you memorizing everything? What's going
No,
on?
I have it written down.
All right, for sure. I was missing. Okay, so now el 6, positive 6. What values? Now I'm gonna worry about the positive 6. What values multiply to positive 6?
2 and 3.
Mm-hmm.
3 and 2.
Mm-hmm.
-2, -3.
Mm-hmm.
And -3, -2.
Mm-hmm.
And 6 and 1.
Mm-hmm.
1 and 6.
Mm-hmm.
-6, -1.
Mm-hmm. And the same thing, yeah.
And then -1, -6.
Right. So again, this is how it is in the beginning, Luca, right? Eventually you don't have to do this, but in the beginning you have to. Once you start doing 2, 3, you start seeing the pattern right away. Maybe you see the pattern right now. Anyways, okay, so that's right. It could be either this guy and this guy together, and we can have 6x minus 6 and x minus 1. Maybe that's it.
Yeah.
Right? Or maybe not. Who knows, right? But anyways, we need to try what's going on. Again, we don't want to do mix and match, right? We don't want to just try one after the other. We don't want to do that. We want to like strategically eliminate as much as we can so that what we're left with, we use our brain power just to focus on that information after we filter out maybe this one, you know what I mean? Quickly.
Yeah.
And what's going to help you do that?
The 13x.
That's
positive
right, dude.
13x.
That's right. You know the value has to be positive 13x. And we already discussed that if you have a number here, what is it going to multiply with?
The number right next to it. Yeah.
That's right. And if you put a value here, what is this going to multiply with?
The first number and the next.
Right?
Yeah.
Those are the ones that we care about. So think about it. We have 6x. So if we choose 6x here, whatever I put here is going to multiply with 6x, right?
Yeah.
So would I put 6 there?
No.
Why not?
Because 6 times 6 is 36.
Excellent, dude. Excellent. So you know that here, if you put 6x here, you can never put 6x. That's humongous. So that option is obsolete. That's option you cannot do. So right off the bat, the possibles of having 6x here and having 6 are gone. Whether it's negative, whether it's positive, because that value is going to be too big.
Yeah.
Right? So that's one thing that you can eliminate off the bat. Right?
Mm-hmm.
So we want 13x. So based on this value, you have 6, 3, and 2. Can you think of maybe what multiplications that you would get close to 13x? You know what I mean?
6 times 2, 12.
6 times 2 is 12. Good. All right. How much would we? What are we missing? How many are we missing?
1.
1, dude. So
Yeah.
so 6x and what'd you say? It was
And
6x
2?
and 2.
Oh, 3. Yeah, 2.
Yeah. So it was 6x and it was positive 2 here over here, right? What's that? 6x times 2 is
12.
12. So you need one more x. Can you get that?
Yeah. You do x and then it'd be x and you multiply x by something or x and 1, like, because on the it has to be in pairs. So for 6x and x, there would have to be the x that follows because like that's like the pair that you're using, right?
Okay, that's what you used to say. Okay.
And then for the positive 2, what? Oh. Let's hurry up. Yeah. It has to be in the 2 pairs that like
Exactly. Which are the only possibles that has a 2? The positive 2. It's
the 2 and the 3.
That's right. Is there another positive 2?
The 3 and the 2. I mean,
That's it. It's just this pair. That's the only one that's there.
No.
Is there another 2 on this side?
No,
No.
that's it.
That's the only pair. So it would be 3. Right?
Yeah.
Does that work?
It does.
Does that work
Wait.
though?
Yeah.
Would that give us a positive 13x?
So it would be 6, 12, and then 3x. So and that'd be 3 times x, and then it would be 3x. So then it'd be 12x plus 3x. So wait, so wouldn't?
Yeah, that's right. What is it?
It would be 15x.
That's right. So that's not it. But
Yeah.
that's exactly the thought process, right? You're like, what if? So now you know for sure that can't be it. So you eliminate those, right? But so what? Now, do you want to give it a shot and see if you? Yeah, I'll do it. I'll do it for you. So let's do it because you already kind of did that exhaustion of brain power because that's exactly how the process needs to go. This whole thing that they do that I saw, right? It's the same thing, dude. You're still kind of like testing it out. You're putting number, you erase it, you try another one. But this is what made sense to me, right? Okay, so I want to get 13x, and I know if I put 6x here and I put whatever value, those two are going to multiply. Okay, so I want to get 13x. I can have 2x and 3x. Let me try those out, right? So 2 times 6 is also 12. That doesn't work. 2 times 3 is 6. 3 times 2 is 6. That's 6 and 6. That's 12. That doesn't work either, right? Is there even, dude, can we even do it? Hold on. So it's 6. 6 would be 3 and 2. Let's see. What if we do 6 times 3? That's 18.
Yeah.
And then 2 times x, that doesn't work either. So, what could it be, man? Just think about it. I'm actually going to look. I don't want to think too much.
The first one.
Mm-hmm.
3x plus 3x 2x 6. Oh, and then so then it would be 3x and then 2x and then
Okay, so let's try that, right?
first one it would be 3x and that one would be 2x
Mm-hmm.
and then the last one would
So I want to, this is, and
but I just have to think about it. It's just
okay.
I have to look at all of them.
But that's fine, dude. Like, so let's think. So 3 and 2, right? So whatever we put here is going to multiply with 3. So what are my possible options, right? So 3 times 3 is 9. Okay, 9. 9 seems to work, right? That's less than 13. So let's see what we get on this. What?
It might be because so that would be 9, and then the one in front would be 2, and then that would be 13.
All right. So what do I write inside?
So it would be 2,
Mm-hmm.
positive 2, and then positive 3, and then
That's right.
and then it would be 3x, and then times 3 9, and then 2 times 2, and then 4 or 4x, and then that would be 13x.
That's right, dude. Winner. That's right. That's it. And that's what makes this part complicated, because even though you get it, the only way to is to do a couple more problems. But that's it. Okay. All right. So next topic. Okay. And I'm gonna I'm gonna use this. Actually, not this one. I'm gonna use a simple one. And just to finish this off, it's this, right? We just set it up. 3x plus 2 equals 0, right?
Yeah.
So let's do that problem. That equals x equals negative 2 over 3. And then the other one, 2x plus 3 equals 0. X equals negative 3 over 2. Yeah?
Yeah.
All right. All right, dude. What is going on with, let me see, with graphing quadratics, right?
Yeah, I'm pretty bad at it, not gonna lie, bro. Like I just haven't, bro. It's just I can't make sense of it. I don't know, bro. I don't even know what she's saying half the time, so.
Graphing quadratic equations, right? All right, so let's use a little bit of not common sense, but let's use a little bit of general information about graphing this. Do you know how to graph that?
Yeah. So the y.
How would you do it? Well, how would you set it up?
The y would be the.
Don't worry. Let's. I'm gonna teach you.
Once you refresh it back, then I'll like start to get it more. But it's just because we learned it a couple of units ago.
Hey, dude, I'm not judging anybody, dude.
Yeah.
Don't trip.
I just forgot it. Like it's just some of the stuff. It's like it's on like like the test that we keep doing, and then I end up forgetting it, and then I have to think of I have to try and remember it again. It's I don't know why I keep, forget it that easily. It's like I learn it, and then I don't care to keep it with me. So
you think it's how much you care about something that you don't keep, like you forget it?
yeah,
No, it's
I
not.
mean in math, I mean
No, no,
yeah,
no, no. It's not. It's not like that. And it's not like that. I personally, dude, it's not like that with anything. You can care about something so much, you can just care about it and spend no time on it.
yeah,
You can care about someone so much and not spend time with them. And spending with time with them, think about it like what you're gonna do here. Spending time with something, you're gonna you're gonna find things about yourself through the process, and that those experiences are what develops and strengthens you. You holding on to information longer is you walking through that experience with it. It's not how much you care about, because there's things that you don't care about that you actually invest in and you become really good at that. You know
yeah,
what I mean? So it's different. Anyway, that's just my 2 cents. Okay, let's go back. Yeah, because sometimes I even bore myself on talking. Okay, so y equals x squared, right? So let's graph that. I'm gonna show you what that is. So normally, if we go back to y equals mx plus b, does this look familiar?
yeah,
Right? You have m is the slope,
yeah, yeah, yeah.
b is the y-intercept, right?
Yes.
And then what's your slope?
Uh,
Rise over run,
yes, rise over. Okay.
right? Is this thing that goes like that, right? Rise over run.
Yeah.
And that's dependent on what m is, right? It's normally a fraction, right?
Mhm.
So if, anyways, you get it. You remember that, right?
Yeah, yeah,
Yeah,
now,
no,
yeah.
okay.
I remember why.
Now, and what's one of the things that we would do, or they would teach you, is they would set this up. Ugh. And the reason that we make you set that up is because they would ask you to choose some values for x, and you plug
Yep.
them into the equation, and then whatever the y is, you like, oh, that's its pair, oh, that's its pair, right? And then you get points. These are actual points. And what do you do with those points?
You brush them.
Oh, point over here. Oh, another point over here. Oh, point over here, point over here, point over here. Oh, what? That's
Yeah.
the shape of an x squared, dude. It's always going to be like that. It's going to be a u. Now, where that u is, if this is your graph, that you can be here, that you could be here, that you could be like really thin, or it could be really fat, right? Or even
Uh-huh.
or it could be upside down. But the shape is the u. That's this guy. As long as you see an x squared, that is gonna be a u, a parabola. That's what it's called.
Yeah. The parabola. Yeah, that's on my packet, I'm pretty sure.
Right? That's what it is. It's a parabola, right? Now let's see how it would look, how this parabola looks. Okay? So let's choose some values. Write this down with me. Okay? So write this down, and then we're gonna choose -2, -1, 0, 1, and 2. We're gonna choose those values as, right? We're gonna plug them in. Okay?
Yeah.
So I'm gonna plug in the first one, this one, in here. Y equals -2 squared.
Yeah.
What is that gonna be?
Uh, 4.
Right, positive, right?
Positive 4. Yeah.
Great. Yes. So let's write +4. Ah. So what would the other values be? Finish them up, please, and let me know what you get.
All right. The second one would be just 1, and then
Okay. Yeah.
0,
Mm-hmm.
and then 1, and then 4.
What would the next one be? This
0,
one. Uh-huh.
and then 1, and then 4.
Why? Why aren't these negative? Or why? What? Why? You see something? What happened?
It just went from, or it
Kilos, man. Yeah.
It just it just went down back up like it went 4-1-0 and then 1-4. Like it just went from up to down and then back up. Like it's like the one going up like that. Yeah, that one. Yeah.
You know that, yeah. And the y, what's the y value? What does the y value represent in a graph?
This.
Don't worry. This is
I
what it
think
is. This is what it is.
this is what
This is what it is.
Oh yeah, like
What is it?
just
What
like
is
the
it?
y.
What is it?
Yeah, what the y-intercept or the
No.
axis?
Yes.
Oh
The
yeah.
y, this y represents the values along the y value. That's what that represents. So when you see this, when you like this, you can actually get an idea of how the graph is going to look by looking at the y values. Because in the graph of a parabola, right?
Yeah.
I mean, you go left and right, yeah, but like what matters is like up and down, like the parabola, that's its main function. It's a u,
Yeah.
right?
Mhm.
Right? So that's the thing. And in this case, they're positive, right? It goes from like a positive number down to a lower number and back to a positive. So that gives you a pretty good idea that it's going to go like that. But if this was negative, wait, would it? I guess. Yeah, yeah, it would. If this was negative, that means it would go
Up to that.
exactly because the biggest value is actually, I mean, the biggest value is negative, right? So that means it's going to be further down. But in this case,
Yeah.
they're positive. So, anyways, hopefully that makes sense. Okay, so now I'm going to graph it, okay? Let's graph it. And then this is 1, 2, 3, 4. 1, 2, 3, 4. 3, 4. 1, 2, 3, 4. All right, let's do that. This is the x. This is the y. So please draw this graph for me, please.
Yeah.
Okay, so now let's just do the points, right? We have -2 and 4, 1, 2, and then 4. That's up here. We have -1 and 1, 0, 0.
Yeah.
Okay. One of the
And
things, you good? This is good, right?
yeah.
Makes sense. Okay. And I just want to kind of, brush through this because this is simple. This is the basic how to find out values for x, solve for y, you get a couple points and graph it. Okay? But now before we continue, I want to just show you a couple things. There's a value here or a certain location where the vertex is. The vertex, way to just memorize it, dude. Think about the V. The V has like a sharp, like a
It's just like the in between, like
it's
the halfway.
it's this guy. It's
Yeah.
this exact point. That's the
Yeah.
vertex. The moment, the exact point that it starts going opposite, it starts going back up again. And or another way to think about it, this is the way I like to think about it. The vertex is going to be the place on the x-axis, on the x value of this parabola, where the left and the right are going to be a mirror. What do I mean by that?
Yeah.
It's like as soon as I know this vertex, as soon as I locate the vertex, which is this guy,
Mhm.
vertice, who knows? But it's a V word, right?
Yeah.
Along that x-axis, I see it like as a mirror, a reflection.
Yeah. She.
As if I fold that paper in half, this this line and this line are gonna be like on top of each other. Yeah.
Yeah.
So that's why it's important to find the vertex. Now, how do you find the vertex? Well, think about it. If and not just and the vertex is if you think about it this way, that it's the mirror, like the location of the vertex creates a mirror on both sides, right? It's like a
Yeah.
reflection. What can you tell me about this value? How can you figure that value out? If it's right in the middle, it's a reflection on both sides. What can you do?
It, it's just gonna be point in between the two.
Exactly. It's going to be in between this entire stretch,
Yeah.
this entire stretch, this one, this one, this one. Any stretch, any value from here, and it's cross, right, partner, this distance, that distance, right?
Yeah.
If you get this distance, what do you want to call that distance? I don't know. Who cares? I'm gonna call it. Let's say. I'm gonna call that. Let's say. I don't know. This D for distance.
Yeah.
Let's just call that D. It could be anything. So, if my vertex is a point, right? And in this point, this vertex, we know it's the middle. If I know how long it is, if I know that distance from this line across to the other, if I know this distance, what can I do to find this value? You get this value and this value, and you measure what the distance is, and what do? You divide by 2.
Yeah. Yeah.
That's what you were thinking, right? So once you divide by 2, that gives you what that x value should be. It
Yeah.
gives you what that x value, and that's this guy. And in your class, in your what's it called? And oh my god, not your class. The worksheet that you showed me, they show it a little bit different, but it's the same idea. And I'll explain it later. But it's the same idea. But that's where it comes from. That vertex, that example that your teacher says, hey, you need to find the vertices of the vertex or something like that, right?
Yeah.
That's the logic. That's the concept behind it. The vertex will always be the distance between the parabola, right? Divided by
Yeah.
2. Okay, that's what
Uh-huh.
that is. Okay,
Yep.
and then if you know this value, Mr. Luca, if you know what this value is,
Yeah.
can you figure out what this guy is?
Uh, it's just gonna be on the. Oh wait.
So let's say you know this value. Like this is I mean we just know that that's how you figure out the x value for the vertex, right? It's this distance divided by 2. So that's what this is. That's our x value, right? For our vertex. If I wanted to know what the y value is for my vertex, what can I do now that I know this guy?
The mm, oh, you find like what the pair is like with that number.
Okay, so how would we find this? What would I need to do?
Well, first you would find what the point is.
Yeah, so let's say you know what this is, right? What would I do with this now that I know what it is? All right, let's.
You would
Mhm.
you the, so you have the number.
Mm-hmm.
So you would look which like which pair it would be in, and then that would be
How would I figure that out though? How would I figure that pair?
oh how would you find like that first number?
How would I find this number? So, here, let's not get too confusing. Let's not, because it's not that confusing. I'm gonna go back here. Okay,
Yeah.
this helped us graph this, right? We had nothing when we started. All we had was this, the quadratic equation. In this case, it's y equals x squared. That's all we had, right? And I
Yeah.
said, Back when you learn how to graph, the most basic way to graph is this. You create your X and Y t-chart. You select some values for your X's, right? Because we want to get some values. We choose some negative values and some positive values so we can get, some points,
Yeah.
in a wide range of the graph so we can see a little bit more of it. So this is what we choose. Those are our values that we choose. Those are my X values that I decide to choose. How do I figure out the Y value? What do I do? How do I figure out this guy's pair? What do I do?
Figure out the Y.
How did we figure out that? Because we had the values. I'll put the values again. Nice done. How did we get these values?
They were. Let's see if
Okay.
we.
No. I got to explain that. I can't move on if this is not if it took you this long to tell me the answer, it means that it didn't click when I explained it. Okay. So I'm gonna go to a simpler example. Okay. Nice, me right there. Problem there. Okay. Can you graph that? Can you graph that if I ask you, okay? Can you tell me some numbers or what would you do? What would you do? How would you graph this?
Yeah, it would just. So X would be 2, and then Y would be 1.
Like that?
Yeah,
How'd you get that?
because 2X and then the 1.
Tell me how you got that 2x and the 1. How did you get 2 and 1? Where does the 2 come from and where does the 1 come from?
The 2 comes from the 2X.
No. Okay. That's okay. Strip that out. It's completely wrong. Okay? Completely wrong. Take that idea out. This is what they give you. When you're trying to graph. You're trying to create this graph, whether it's going to be a line going this way. So all I'm saying is here we're trying to graph. That's the goal here. And this is the equation they give you. The equation they give you is y equals 2x plus 1. All right?
Yeah.
When they ask you to graph it back, this is like pre-algebra stuff, dude. And I'm going to explain it so that it comes back. Because the core thing about that lecture was that when you graph, this is your opportunity for you to decide how you want to graph it. This is what you get, and you're like, okay, what am I going to do to graph this? Okay? So this they introduce this t-chart the very beginning because what they do is like, okay, think about you have this graph, right? This equation is going to make some figure, some line there. Okay?
Yeah.
But it's dependent on points. It's dependent on an x and a y point. And
Yeah.
do you know the relationship between the point and this equation? The relationship between that? The relationship between those two is this. This is the line. So let me draw it really quickly so it makes sense. So let's say I have this graph, right? This is my line. Let's just say this is my line. That's this graph, right? That's what this is. Each along this line, there's an infinite amount of points. There's a lot of points here. So many points. And each of these points, each of those points has an x and a y value. Do you agree with me? So if I choose a point like this here, there's an x value and there's a y value. Does that make sense? Yes. So when we want to create the graph out of an equation of a line, we choose our x values. You decide, okay, what values do I want to choose along the x axis? Because if I choose this value, maybe I can know what the y value is. And the way you would do that is you would choose numbers on your own on the x-axis. So I would choose, let's say, -2, -1, 0, 1, and 2. I could choose -5, -3, -1, 0, 1, 3, 5. So that's what you decide. It doesn't come from here. That's what you decide what to choose. If you decide to choose, let's say, -2 here, that's what you're choosing for the x value. So you're saying, I want to know what that point is if my x value is -2. So that would be like over here, -2. So let me erase this whole thing now that you kind of got the idea of what I'm trying to do. And now what I'll do is I'll actually write I'll draw the graph exactly. So this is my, okay. All right. So what's happening here is I want to know if this is my x-axis. That's my x-axis, right? I want to know when it's when it's -2 along this line. I want to know where that line is. Where is that point of that line? So I would just get this value, and then I would plug it in for x.
And then multiply it by whatever the number is.
And what would it be, right? If I plug in -2 there, what would it be? What would y be? Well, y would equal 2 times x plus 1. This value is my -2. That's what I'm choosing for x to be. Because this line, this equation represents the line on the graph.
Yeah.
And on that line, you're gonna it's what's it, well, it's compiled. Yeah, it's compiled of a lot of points, right? And these points, like I mentioned, has an x value and a y value. The x value you choose, so just solve for y. And that's the lesson that I thought you remembered. So how do we figure that out? So if this is my equation for y equals 2x plus 1, I'm choosing x to be -2.
Yeah.
I plug it in. Y equals 2. And then instead of x, I write -2. And what's that? What's y equals 2 times -2 plus 1? What is that?
-3.
That's right, -3. Now you get it. See?
Yeah.
Okay, good. Now let's go back here. Let's go back here. So in this example, our equation is that's what we're trying to graph.
Yeah.
Now you understand where these numbers came from?
Yes.
Where do they come from?
We just that was like what we decided to put there.
That's correct. That's what we decided. What my x values I want to find what the y value is, right? What their point is, right?
Yeah.
So now that I've told you what we talked about earlier, how did I get 4, 1, 0, 1? How did I get those?
You did y, so you did negative. So you plug the -2 into the x, because
So where would this come from?
so that would be from the answer.
Y equals what?
Y equals -2 squared.
That's right. So that is where these are coming from. Exactly. So if you know the x value, right? You can I'll just plug it into the x and I get my y. And now I got my point. So my point is -2 and 4. And here it is.
Yeah.
Good? Good?
Yes.
Say. Now this is the question. I'm going back to the question. So I did all that to get back to to this question, right? The question is, the vertex, we know that this is the point where it's a reflection of the graph, right? Like it cuts it right down the middle, right?
Yes.
So we concluded that the x value, right? The
This-
point, the x value is the distance between these two opposites divided
Divide.
by 2 because
Yeah.
it'll be the middle. So we named this to be, we don't know what that distance is, but let's call it d for distance right now, right?
Just
And
yes.
then distance, once we find that, we divide it by 2, and that's my x value. So for here, this is my x value, right?
Yeah.
So if this is my x value for the vertex, d divided by 2,
Uh-huh.
how can I find the y of the vertex?
If D, you plug that x into the equation,
So how would you find the vertex? So if this is my y, what would y equal? Tell me.
y
What would the equation be?
y equals, and then the distance would be, well, the distance would be 4, right? 'Cause, like that's
Okay, again, let's make it simpler. I'm gonna have to go back because I just want you to put the two things together. You're really close. I'm gonna go back here. How did I get 4? How did I
you
get this point?
you put the -2 into the equation, and then the answer was the y.
Okay, and why did I do that? Why did I put this -2 into what equation?
Into the, because that was the equation that was given. It was
What
y
equation? Just tell me. Say the
into y
equation.
equals x squared.
Okay, that's the equation. Y equals x squared. Okay, how did you get this 4?
That was the answer to the equation.
How did you get that 4?
You plug the -2x into the y equals x squared, so it'd be -2 times -2, and you got 4.
Okay, so again, that's my y value for this x value, right? So you plug
Yeah.
this x value here to the equation, right? And
Yeah.
then you solve it, and that gets your y. Okay, so in the vertex, right? The way to find the vertex, or at least the x value for the vertex, right? The vertex is a point. We mentioned that the vertex has a point. It has an x and a y value. It has a point.
Yeah.
We said that the x value, it's where is it going to be? We concluded that it's going to be in the middle, right? Whatever the distance is, it's going to be right down the middle. Because it's a reflection, so you know that. So we said, okay, I don't know what this is right now. I'm just going to name it d for distance, the distance between this entire thing. So that means the x value for the vertex is the distance divided by 2. That's my x value for the vertex.
Okay.
Right? Because that's where the middle's going to be. You know the
And
distance between this. So how, now that you know that, how would
that
I
would,
get the value of the vertex?
ooh. Okay, so the distance over 2, that would be 0 then, because
No,
that's
no, don't solve it. Don't solve anything. I don't know why you're trying to solve the answer. I'm not asking you. Hey, have I asked you, hey, Luca, what is x?
no, no,
No,
no.
no. Forget about solving for x. You already know what x, you already know what the x is of the vertex. Say it. What is it?
It's 0.
No, 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 no. What is this? What's the vertex? Say it.
Oh, it's distance over 2.
Bro, it's distance. It's this divided by 2. Don't
Yeah.
solve it. Don't give me the answer. I know that might be confusing, but I've never said 0. I want you to get the concept of this. So if this d over 2 is how you get the x value for the vertex, right? That
If,
that that's your x value. This is your x value. How do you
yeah.
get the y? Set up the equation to get the y. How do you get this value? I'm going to ask you again. How do you get this value?
You when you plug distance over 2 into the,
That's it. That's it.
you
You don't it's not that it's not more than that. Math, dude, it's and I'm sorry, bro, because like what school does, school kind of like sometimes along the way school isn't perfect, but Math is this subject, dude, that it could either be very complicated. You can have a very complicated journey along the way, and you structure your brain to overcomplicate what math is really intended to do. So you're structured that way. So now when I introduce something, I'm kind of looking for a really simple answer, and you're trying to like solve it, create this, like what, you know what I mean? Because that's the way you. And then all of a sudden you're like, not right now that you figure it out, you're like, oh, dude, that makes, dude, it's exactly the same thing. I don't need to solve it. You were doing a step in between, but that was because the way you were meant to. You were taught how to do things. So going back to this, yes, Luca, este de aquí, this y, right? This one is, what would it be? Tell me.
0. Oh, no. It would be, wait. We just said it was distance over 2.
What is it gonna be, dude? I'm gonna have to explain the whole thing again. I think I am.
Bro, okay, so to get y, we would plug the distance over 2 back in to the equation. So y equals x squared.
Okay, so what would this y value be? What would be the vertex of the y values? Tell me what the equation would look like.
It would be y equals distance over 2 squared.
Yes, that's it.
Oh.
I don't want you to solve it. I want you to get the
Oh,
concept, because once you understand the concept, it applies to every single problem. This is easy, dude. The quadratic factoring that we were doing, that's hard. That's harder than this. This is plug in. Let's just follow the same little steps. If you want to know what y is, do you know what x is? Yeah, okay, plug it in. All right? Okay. So those are the main things about the vertex. The vertex is going to be always that middle number. Okay? Now,
yeah.
okay, so I think this is a good place to stop, to be honest. Tomorrow we're gonna go again, and because tomorrow we're gonna go through the actual graphing of problems, and knowing the x-intercept is, the y-intercept is, right? But
Mhm.
right now, we'll just do one together, okay? Just follow with me on this, okay? And
All
this is
right.
gonna be your example, and it's not, and it is your homework. It is gonna be your homework.
This is not. This one I'll do is because I had a college, my college final stuff, and then they ended up moving it. So
Okay. All right. So yeah. So like, what's gonna happen is I'm gonna go through the example, graph it, kind of set up the whole thing, write it down, and kind of go through it. And
yeah,
tomorrow we're gonna that's the lecture that we're gonna learn. But I do want you to at least go through it before class tomorrow, okay? And the only reason that I'm being a little bit pushy like that is because you have your test on Thursday.
yeah,
Okay. So graph. Okay. So let's graph that simple one. Okay.
yeah.
So the way that I'm going to show you how to graph this is going to be, we're going to factor. So we're going to factor.
Yeah.
We're going to solve for 0.
Factor.
Okay. And
Yeah.
then we're going to find the vertex or vertice, whatever they name it, right? We're going to do that.
Yeah.
Okay. So first thing I want to do, I want to factor. That's my go-to thing. I want to factor.
Yeah.
So I'm going to factor this guy. So right off the bat, I know that, what are my first two values?
X and X.
And what would be my other two values, dude?
Uh, it would be, oh yeah. -3 and 2, or
No, which one is it? -3 and 2? Okay. -3 plus 2, like that?
oh wait, no. It would be 3, +3, -2,
Why?
because it has to be. X has to be X. Yeah, and X is 1, so
Positive,
3.
positive, right? Is bigger.
Yeah,
So yeah,
yeah,
good.
it has to be positive. There
Nice.
you
All
go.
right. So now when I get here, when I factor, the next step that I could do is, again, I'm trying to graph. I'm trying to create the picture, right? I'm trying. So let me right now what I'm gonna do. I'm gonna draw the graph. Okay, draw it with me. Okay. This is my X. This is my Y. It goes on forever. It goes on forever. It goes on forever. It goes on forever. Okay. And they go by ones. They just go by ones, right? So that's my graph.
Yeah.
Now remember, a graph is consisted, like, we know this is an x squared, so no, we know it's gonna be like this. We know it's
Yeah.
gonna be a parabola, right? We know it could be like this, like this, like this. I mean, you know if it's gonna be upside down or upside. You know? Do you know why?
Yeah.
Do you know if it's gonna be upside down or upside up?
It's going like
Is it like this or like this? Is it option A or option B?
option A.
Yeah, and the reason for that is because this guy's positive.
Yeah.
Okay, the extra positive. Anyways, okay, so in the graph, when I factor it, a graph, again, like I want to repeat again, the goal is to draw the picture. And to draw the picture, a couple things can happen. They can cross the x-axis. It could intercept the x-axis. You see that? It intercepts there. It kind of like the line kind of touches.
Uh-huh.
That's why it's called intercept. The line is intercepting the x-axis, right? So, and then what would this be?
The y-intercept.
Exactly, the y-intercept. Now, what can you tell me? What's unique about the x-intercept, and what's unique about the y-intercept?
There's 2 x-intercepts,
Good.
and
Okay.
then there's 1 y-intercept.
Okay.
Um.
Think about it. I mean, it's a parabola, right? We've talked about it. It's like a reflection. Like use the stuff that we've already kind of talked about, right? So I'm gonna, again, I'm not gonna. It's not another lecture. This is what I'm gonna teach you next time,
Yeah.
right? But this is what it is, dude. If you notice the x-intercept, it crosses the x-axis. That means it cuts the x-axis, right? Now, if you notice in these two positions, what's the same is the location on the y-axis. Along the x-axis, they're in different places. But
Mhm.
along the y-axis, they're in the exact same place.
Yeah.
So when you have a parabola, you have parabola, and you have this guy and this guy are the x-axis, are the x-intercepts.
Mm-hmm.
The x values are different. I don't know what they are. But what about the y value? What do you think the y value is?
It's it's gonna it's gonna be the
What does it intercept? It's intercepting on the x-axis. It's intercepting here. What's the y value along the x-axis?
0, 0.
Yeah, but look, yeah, because what's the y-axis, Luca? What does it do?
The line intercepts
What's
with
the
the y.
y-axis? No, what's the y-axis? The axis, the y-axis. This guy. What's
Yeah.
this? What does it do? What is it gonna tell you to do?
If it's if it's if it's negative or like positive,
Okay, yeah. So if y is negative, y is positive, what are you gonna do?
um
What's the function of the y-axis? Like, what's the main work? If the y-axis is gonna go to work, what is it gonna tell people what to do?
oh, if the line's going like that or like that.
Bro, what's the y-axis? What's the y-axis for? What does it
It's
tell you to do? Like the y-axis just tells you to go up and down. That's it. The y-axis, the y value is going to tell you, are you up 2 steps? Are you up 3 steps? Are you down 4 steps? Are you down 10 steps?
Okay.
A point, the y value is along this axis. It just goes up. It just goes up and down. Now let me ask you, what's the function of the x-axis now?
The x-axis.
Yeah. What's the function of the x-axis?
Well, you said that you didn't know the x-axis.
Let me ask
Or
you
like,
again. Let me ask you
okay.
again. This is the x-axis, dude. This is the
Yes.
x-axis. This is the y-axis. We're not.
Yes.
Let's forget about this. Let's forget about
No,
that.
the
Right now,
x-axis is if it goes left to right.
that's
Like,
it.
okay, there you go.
So that's what, and that's important, dude. That I really want you to do that because the x-axis is just you go right or left. Y-axis you go up and down.
Yeah.
Now I'm gonna show again the graph again. This is where they intercept. This is the interception, right?
Mm-hmm.
The x value here and the x value here, are they the same or different?
They are different.
Different, exactly. They're in two different x in two different locations along the x-axis.
Yep.
Okay, what about the y-axis?
It's the same.
Okay, what value is the y in those points?
What value is the y in these points?
Yeah,
It's
what's the y value in these 2 points? If the y value is the same,
0,
right? What's that y value?
You said it was just 0, 0, right?
I never said 0, 0, ever.
Well, I remember you said something about 0, 0 because it was like the x, the only like place where it intersects with the y, it's 0, 0.
No, 0, 0 is here. This is 0, 0. That's 0, 0.
Wait, ask the question again.
What's the value of the y in the points where the line intercepts the x-axis? So this is the graph. It intercepts. This is the point where it cuts the x-axis. This is the x-axis.
Yeah, that's where it hit the x. That's where it hits the x-axis.
So this x value, I don't know what this x value is. I don't know what this x value is. They're different, right?
Yes.
But the y value, is it the same or different for those 2 points?
It's
What's the function of the
same.
y value? Yeah, exactly, the same. Because the function of the y value, that's why I said it is the y-axis, is to go up or down. So look at those points. Are they going up or are they going down or are they not going anywhere?
It's going. Just the 2 points.
Yeah, that's only those 2 points. Yeah.
It's the line. It's going up.
The points? No, the points are there. No.
Oh yeah.
I'm just looking at here and here.
Okay, just the 2 points.
So they're along the x-axis, right?
Yes.
We already you know that this point has this x and this point has this x, right?
Yes.
We don't know the y value, right? But it's the x-intercept. And I want you to really look those points, where are they located on the y-axis? What's the y-axis? What's the function of the y-axis?
If it goes up or down.
If it goes up or down. So look at those 2 points and tell me where they're at along the y-axis.
They're just still. They're just not.
Where along the y-axis? What's the y-axis? This is the y-axis. Tell me, what value are those points along the y-axis? Where is it?
0?
Yes. It's right here. It's right here. Yeah. 0.
That's what I meant by 0. I don't know why I added the other 0, but that's basically what I meant.
Okay, then we're good.
Yeah.
That's exactly it. So this here at the x-intercept, the y value equals 0.
Yeah.
At these 2 points, the y value equals 0.
Yes.
That is why I factor it, because the understanding of the x-intercept is that the y is always 0. It doesn't matter where it crosses. If it crosses here, if it crosses here, if it crosses here, it doesn't matter. As long as it crosses the x-axis, along the x-axis, wherever it crosses any line, the y value is 0.
0.
And why does that help you? Because that is part of your problem that you got on what you showed me today. You set it up like this. So now that you have this you factor it like this. This is equal to y. Well, if you know the x-intercept, actually write this down with me. So x-intercept is when y equals 0. So
Yeah.
therefore, if that's the case, this is what we do. Then this is what we do. We get our equation. And instead of making it equal to y, what do we make it equal to?
0.
0. Because I want to know what my x values are when y equals 0.
Yeah.
And now this is something that you should be extremely familiar with.
Yes.
So what after that, what do? We just solve these guys. We just go x plus 3
Minus 2 equals 0. X minus 2 equals 0. Minus 3 minus 3. X minus 3 plus 2 plus 2x equals 2. Yeah.
Okay, so now you know for a fact that at -3 and at -2, when x is -3, my whole thing, my y is 0, which means that at this point, at -3 and 0, that is an x-intercept. And the other one is also an x-intercept.
Yeah.
So let's do, so we have -3 and 0. Here it is.
It's 2, no?
What is it? Oh, yeah, my bad. My bad, but you're right. See, dude, I even made a bunch of mistakes. So it's 2. There we go. Yep. Okay. So then we have 2, 0. Right here it is, 2, 0.
Yes.
Right? So this is my -3, 0, and this is my 2, 0. Now check this out, Luca. Remember we said earlier that to find the vertex, it's just this distance divided by 2?
Uh-huh.
So since we know what this value is on the x, and we know what this value is on the x, we can figure out this distance.
Oh, you're right.
And then we divide it by 2. That gives us our vertex, homie. That gives us our vertex, our x value. And then after that x value, we plug it into the equation. We get our y. Then we draw our graph. We get our vertex. We get an A on the test, dude. That's what I'm telling you. This is the easiest part. The factoring is hard. All right, so let's just kind of go through this together. So the way you kind of find the vertex. So now after that, so we did this. So we did the factoring. We got you. Gosh. We got the factoring done. We got the solve for 0. So now we need to find the vertex. And then when we do that, this is the way you find the vertex x. So finding the vertex after finding x-intercepts. Okay?
Yeah.
After we need to know that first. Anyways. Okay, so the way we do it, what do? We just take the difference of the two sides. So this is what we do. So the difference is -3. So this is what you do. This is how you do it. You get the first x value. So the x for the vertex, I'm gonna name it is x2 minus x1 divided by 2. This could be my x1. This can be my x2, or vice versa. Who cares? Doesn't matter. It's going to be the same thing, right? So let's do that. So my vertex x. So this is what I'm talking about, my vertex x. So my vertex is this, right? So it's gonna be like this is what I'm talking about, right? That's what I'm saying. That xv is gonna be that x value for my vertex. Does that make
Yeah.
sense? Okay. So then in this case, x2 I said to be 2, so I'm gonna solve this. So this is 2 minus, and what's x1? -3 divided by 2. What is that gonna be? So that's 2 plus 3 over 2, which is what? 5 over 2, which is 2.5.
2.5.
So my vertex first point is 2.5, right?
Yeah.
So I don't like to use 2.5. Never use fractions. It's lame, dude. I mean, never use decimals. It's lame. Use fractions. It's much cooler. All right. Yeah. So 5 over 2. So now how do I find the y value for the vertex?
You do the just
How do I find my y value for my vertex after I found out what my x value?
oh,
So let me go back. Okay.
you plug that into the equation.
That's
Like
right.
what we had before.
That's right. So let me first locate this value x, because like what this is 5 over 2. So let's just 5 over 2 is 2.5, we said, right?
Yeah.
Oh my god, I made a mistake, I think. It's not minus, dude, it's plus. My bad. Dude, I'm so but it's the same thing. It's the same thing, but not the same answer, but it's just
Same way to.
Oh my goodness, plus. My bad. Here it is.
So,
So then this would be, what would it be?
it would be just 0.5.
So it would be minus, right? So then it would be -1. So it'd be -1/2.
-1/2. There you
Right? So it would be -1/2 is
go. Negative
here.
0.5.
Here it is, right?
Yep.
So this is my mirror. The distance from this point to this line and the point from this line to this line is exactly the same thing. So okay, so now that we got that exactly right, Luca, we plug it in into the equation, which is y squared. Which is y equals x squared plus x minus 6, right? So let's plug that guy in. Y equals -1/2 squared. So we have this. Okay, so then if I solve this, y equals, this becomes positive. This is 1/4 minus 1/2 minus 6. The y equals, dang, what is this, dude? 4, 1 minus 2 minus 24. Y equals -25 over 4. What would this be? 4 times 6 is 24. It's like around 6 point something, right?
Yeah.
So that means that it's 6. So I'm not gonna write I'd rather write the, what's it called? The fraction.
Yeah, it's great. Yeah.
So that's, what was it? -6. So look, it's gonna be all the way down here, dude. So this vertex is probably gonna go all the way down here. Like 6, 1, 2, 3, 4, 5, 6. It's gonna be, so it's gonna go like this.
Okay.
Okay, so this is what we're gonna do next time, dude. This part.
Right.
But I'm glad that you kind of followed through.
Yeah.
Okay. And if this makes sense, and if you review your sheet, this is exactly what's on your worksheet.
Okay. Oh yeah.
Dude, there's a lot, but you're preparing for the test. Take a break, dude, and then I'll see you tomorrow.
All right.
Bye,
All right.
Luca. You got it, man.
Bye.
Bye.